Epidermal growth factor receptor, or EGFR, is a transmembrane tyrosine kinase, which is responsible for regulation of cell growth and normal cell differentiation. EGFR plays an important role in NSCLC. In all histologies of NSCLC, including squamous cell carcinoma, tumor cell survival and proliferation are driven in part by EGFR. Most NSCLC tumor cells have normal or wild-type EGFR. However, in about 10 to 30% of NSCLC tumors, an activating mutation of the EGF receptor is present within tumor cells. In EGFR wild-type tumors, the EGFR pathways, in particular PI3K and MAPK, play an important role in regulating cell survival and proliferation, although additional cell signaling pathways are also believed to be active. Wild-type EGFR is activated through a process of ligand binding that leads to receptor dimerization. Following dimerization, ATP binds to the tyrosine kinase domain of the receptor, initiating multiple signaling cascades that result in cell survival and proliferation. Though there is a degree of crossover, PI3K is mainly responsible for promoting cell survival, and MAPK for cell proliferation. Proposed mechanism of action for Tarceva, erlotinib. Tarceva was designed to compete with ATP for binding in the tyrosine kinase domain of the receptor, thereby inhibiting the EGFR signaling cascade and therefore PI3K and MAPK activation, which may impede the tumor's ability to survive and proliferate. Mutated EGF receptors have been shown to dimerize without ligand binding, leading to continuous signaling through the EGFR pathways. As a result, EGFR mutated cells may significantly reduce their reliance on other survival and proliferation pathways, making them hyperdependent on EGFR. Therefore, EGFR may be even more crucial for these tumors to survive. The PI3K and MAPK pathways of EGFR mutated cells are both abnormally overactive, but PI3K shows a much higher level of activation. As PI3K is responsible for promoting cell survival, its inhibition could induce a greater degree of tumor cell apoptosis in EGFR mutated cells than in EGFR wild type. Another proposed effect of the EGFR mutation is a change in the shape of the binding pocket. This change is thought to enable preferential binding of Tarceva, making Tarceva even more efficient at displacing ATP in the binding pocket and preventing the EGFR signaling cascades. There are important differences between EGFR wild-type tumors and EGFR mutated tumors. However, based on preclinical studies, both tumor types are believed to be dependent on EGFR for cell survival and proliferation, and both are sensitive to Tarceva. This is supported by extensive clinical data demonstrating the proven efficacy of Tarceva in EGFR wild-type tumors and most recently in patients with EGFR mutated tumors treated with Tarceva first line.